Hello, welcome to Ascending DC channel. We are an AWS certified partner to provide cloud consulting and technical support to clients who are looking for cloud solutions to tackle the challenge in their day-to-day operations. This video is one of the many short videos we are producing. In each of them, we're going to demo and explain one useful AWS practice that can be used to improve the efficiency and accuracy of your work. All these tricks have been proved effective in our clients' success. If you are a project manager, DevOps, architect, software engineer, or just looking for useful cloud practice, this video is made for you. Please like, share, and subscribe to our channel. Thank you.
Hello, everyone. Today we're going to talk about a little bit different topic, Snowflake. We have recently done a lot of work with Snowflake. Today, one of Ascending engineer, Tommy, is going to talk about how to ingest data into Snowflake from AWS with Snowpipe. Tommy, you're up.
Okay. Hi, everyone. Today, I'm going to talk about how to build an automated data ingestion process from AWS to Snowflake by using Snowpipe. We will cover two different scenarios. First, we will demonstrate loading data from S3 bucket to Snowflake with Snowpipe for unencrypted files. Second, we will talk about our experience on how to load encrypted data from AWS to Snowflake. First, let's talk about Snowpipe. Snowpipe is a serverless, scalable, and optimized data ingestion utility provided by Snowflake for continuously loading data into Snowflake tables. It's especially useful when external applications are landing data continuously in external storage locations like S3 or Azure Blob, which needs to be loaded in Snowflake as it arrives. Now let's take a look at the overall workflow for Snowpipe data ingestion from S3. Firstly, we need to set up all the security and permissions in your cloud environment. Let's take AWS as example. We need to set up IAM policy and role for permissions. Second step is to create stage and pipe object in Snowflake. And finally, we will enable auto ingest with Amazon SQS. Let me demonstrate IAM policy and permission setup first. So the first step is to create IAM policy with following permissions. As you can see here, we have S3 get object, S3 list bucket, S3 get bucket location, and S3 get object version. The second step is to create an IAM role. So let's go into IAM role and create IAM role. Select another AWS account as a trusted entity type. In the account ID field, enter your own AWS account ID temporarily. Later, you will modify the trusted relationship and grant access to Snowflake. Now, select the required external ID option and enter a dummy ID such as 0000. Later, you will modify the trusted relationship and specify the external ID for your Snowflake stage. An external ID is required to grant access to your AWS resources, such as S3, to a third party, such as Snowflake. And click Next. Now, we need to attach the policy you just created and make a copy of the AR. So after setting up the IAM role, there are a couple of things we need to create in Snowflake in order to automate the workflow: storage integration, external stage, and pipe object. First, let's create a cloud storage integration in Snowflake. The storage integration is a Snowflake object that stores a generated IAM entity for your external cloud storage along with an optional set of allowed or blocked storage locations, such as Amazon S3. So let's go to Snowflake worksheet and run the following command. Please replace the AWS row ARN with the one you just copied here. After creating the integration, retrieve the ARN for the AWS IAM user that was created automatically for your Snowflake account by executing the describe integration command. What we need here is storage AWS IAM user ARN and storage AWS external ID. Copy them and go back to AWS IAM console. Now we can grant the IAM user permission to access our bucket objects. So click on the row you just created in step 2 and click on Trust Relationships and click on Edit Trust Policy. And now modify the policy document with the describe storage integration output values you just recorded. Once the permission has been established, our next step is to create external stage, setting up event notification for SQS queue and creating a pipe object. External stages are storage locations outside the Snowflake environment in another cloud storage location. This could be either Amazon S3 storage or Microsoft Azure storage, allowing for greater flexibility for potential web hosting and ETL solutions prior to accessing the data in Snowflake. Okay, now let's go back to Snowflake worksheet. First, let's create the external stage. You can also use the existing ones. Then let's create a pipe with auto ingest enabled. The pipe defines the copy into statement used by Snowpipe to load data from the ingestion queue into the target table. Now we should be able to see the pipes we just built with show pipes command. Note the ARN of the SQS queue for the stage in the notification channel column. Copy the ARN so that we can set up event notification for this queue. Go back to Amazon S3 console, configure an event notification for the bucket with the queue ARN you just copied. Okay, after setting up this, the Snowpipe with auto-ingest is configured. When new data files are added to the S3 bucket, the event notification informs Snowpipe to load them into the target table defined in the pipe. We're now able to load data into Snowflake. We also want to share particular use cases in our past work. Sometimes we have to load encrypted data from cloud environment to Snowflake. In this part, two use cases will be discussed. The first one is for files that are encrypted with AWS CSE or AWS SSE S3 and AWS SSE KMS. The second one is for files that are encrypted with customized client-side library. For files that are encrypted with either client-side encryption, such as AWS SE, or server-side encryption like AWS SSE S3 and AWS SSE KMS, we can simply pass in the master key for KMS key ID with copy into command, so that Snowflake can decrypt the file. For client-side encryption, Snowflake only supports using master key stored in Snowflake. You can refer to this link for further instructions. In our second use case, our client uses their own library to encrypt the files. To decrypt the file properly and send it into Snowflake, we used AWS Lambda function with Snowflake.connector so that we can put the file into internal stage and then manually trigger the pipe. As you can see here, after sending the CSV file into internal stage, we can run copy into command, which is much faster compared with ordinary insert operation. In our scenario, we loaded a 50 megabytes CSV file, which is around 50 million records, into Snowflake in about 1 minute. If you're interested in knowing more, please feel free to reach out to support@ascendingdc.com in the comment section. We'd be happy to schedule a call with you to help you resolve your Snowflake challenge. Thank you so much for watching. We will see you soon in our next video.
Thank you, everyone. Talk to you soon. Bye.
Please leave your comments, questions, critiques to us so we know you are watching. Again, please like, share, and subscribe to our channel, Ascending DC, and stay tuned for our next video. See you next week.